Looks like the stream's going. Alright, I'm TigerArcty3, and I thought of some Python stuff stream. It's gonna be a dice rolling program, very small. I think I made one of these, something like that, in Java years ago. It was probably pretty big from what I remember. This one will not be big. It is very streamlined. Easy task. Famous last words. Anyway, first thing I'm going to do is import random. Then I'm going to write a function. Should I write a function? I want to get inputs from the user, and then make dice rolls out of them. So let's see. How about how will I structure it, is the question. Maybe a generator could be good, and a function to call the generator multiple times. Okay. Dice. Let's actually do a roll. Rolls. How about? We are going to need anything? I think that's fine. Rolls. For item in iter input and nothing. So the 2-argument form of the iter built-in function calls the first argument and yields whatever the returned value is, and keeps doing that until that return value is equal to this second argument, which acts as a sentinel. For item in that, yield let's say random. Actually, this would be yield from, I guess. No, let's just do yield. Random dot, how about, actually, let's process this a bit. I want to be able to roll a certain size of die a certain number of times, like a d20 3 times or whatever. So how about let's have the size of die be first. Size and count equals item equals map to int, and we want to split it. So this will split whatever string we enter on whitespace, and then we turn each of those into an integer. And then let's yield each thing. So I'm going to actually yield another generator object in this generator. A generator that yields generators. Fantastic. yield random dot randint from 1 to size for C in range count. Okay. Looks good. Let's try this. For roll in rolls, print star roll. No. Oh, I gotta do this. Sorry. I want a D6 twice. About a D25 times. And that's it. Let's clean that up. I don't like having the inputs I don't like having the inputs being interspersed with the output. So how about result equals list roles. Oops. This D6 3 times, D10 5 times, D20 once. Okay. Print star result, and separate with new lines, and oops, not quite what I wanted. For R in result, print star R. Okay. That's better. Let's make this a function. How about def dice? I'm sorry, what? Oh, yeah, got it. Sorry. Result equals list out of rows, and then for R in result, print star R. Okay, and so I call dice 5 8 9 4 12 4 100 5. Yes, 100-sided dice exist. I own one. They're about the size of a golf ball. Okay. I rolled a 9-sided die 4 times and got 4 each time. What are the odds? About 1/9 to the 4th power? Isn't it fun when rhetorical questions are actually quite straightforward? 3 1 2 1. I rolled a 100-sided die 5 times and got 3 2 1 4 4. That's a little odd. Yeah, should get a different... Yeah, this is right. I just expected them to be a little higher if we can go up to 100. Let's do that once more. 6, 7, 8 of them. These are coming out pretty low. That's a little weird. Why doesn't it give me something to 100? I'm not random 1 to size, so it should be 1 to 100. This is very strange. Give me 20 of them. Okay. Dice. 2, 2, and 120 of them. That's a little strange. Should have been random 1 to 2, and it gives me 33 and 69. That's a little strange. Why is it doing that? Okay, calls rolls for each item in this. Gets a size and count. Splits it on the space, maps it to that. Yield, random.random 1 to size for C in range count. Two. Should only have been 1 or 2 here, but I got 33 and 69. Something is wrong. $22. That's not right. Why is it doing that? This is our rolls. Oh, it's lazily evaluated, I guess. Let's change this. How about? So it's just using the last value for all of them, or something. Let's change that. There we go. 2 and 105. There we go. That's a little better. I guess when I had a generator, it wasn't, it was going through them and just using the last known value of size for each item. I don't know why it would do that in this case. I mean, I saw the problem and solved it, but I don't know why it was doing that to me. For each item in this, yield that. So it requested one, and then yielded one there. Oh, it just yielded a bunch of generators, and then the generators hadn't actually happened yet until I called list on them, and then they got the last count determines the size of the generator, so that would remain. But this over here, count determines the size, and size determines the size is the number of values on the die, and count is the number of times we're rolling it. So yeah, it was yielding a bunch of generators, and those generators weren't evaluated until the last... let's see if we could mess with this in some way. Could I fool it? Let's see if we can fool it and still use a generator. I'm going to try default arguments. One to x. I want to call this. I'm going to group this and then say call it. Okay. Dice 2 and 2 and 105. Nope, that doesn't work either. Okay. Never mind. I thought we could play a little joke on it by changing the closure, but I guess not. It hadn't gotten in there at all. I would have needed to have a closure around the whole thing. That's what happens with generators. They're lazily evaluated. If you have a generator g of yield from range 20, actually, def g for I in range 20, print I, and yield I. Okay. Let's save G. Okay. Nothing has printed yet. So notice that we called the function already, but nothing has printed. B equals next A. So we have 0, and B is also 0. Now B equals next A again, and it printed 1, and B is 1 also. Let's do the following instead. X equals 5. Okay. Def G for I in range 20, print X. Let's actually just do yield X. I think I can do that. A equals G, gotta restart it. Next A is 5. And again, still 5. X equals 9, now we do next A is 9. So what it did not do is go through I in range 20 and check what X is, it's 5, and get a group of 20 of the number 5. It's doing them one at a time. So if this value changes, so does what we get out of it. So that was the problem. They were lazily evaluated, and that's not what we wanted. Let's get the proper one over here. Put all that stuff back. This needs to be that. There. Okay. Great. So that's how you make a dice rolling program I thought that would be faster, but it wasn't because I was trying to use generators. I guess we could do that more simply. Iter input and nothing. The dice and the count equals map int I dot split. Do I want to do this? No, I would have to save a list somewhere. It can't be all generated because I'm saving the inputs. So no. I could do this. Print random dot rand int 1 d for something in range C. I think that's right. D2. Yeah, so I could have generators all over the place. But the key is that I had wanted to save up all of the inputs, do all of those at once, and then afterward print all of the results together. Basically uncollate them. Is that a word? What's the opposite of collate? I have no idea. Collating is, you may have seen this as an option in printer dialogues. If you do not have collate copies checked when you're printing something, and you're printing multi-page documents multiple times, you'll get all the page 1s, and then all the page 2s, and then all the page 3s, and then all the page 4s, etc. And then if you do that, you give them to some poor sap to staple. And you say get one from each pile and staple them together. And keep doing that until they're done. If you hit collate copies, it prints page 1, then page 2, then page 3, etc. For each copy. And then moves on to the next copy. And then all I have to do is kind of find where each one ends and put a bunch of staples in there. It's much easier. So I wanted them not collated. I wanted all of the page 1s, the inputs, and then all of the page 2s, which is the outputs. That means we have to save all the page 1s because the output is based on those. So can't really do that with generators because they will save, they will not actually save the values they are given. They won't look for the values they are given until the very end when they are called. So yeah, that's the meaning of that. Anyway, the final thing is either just this, which simply prints directly, or you can do this, which generates lists of what you need with a helper function of, where'd it go? This. So basically, that's it. 4 lines. Great. So yeah, that's rolling dice for you. Or actually, no, this is input and then output, input then output. So these are different. You could do Map int I dot split for I in range, no, for I in iter input and nothing. I think, can I do this, I wonder? L equals that. Would that work? No, I would just be the last one. Let's try that. Actually, no, I would be the last value, wouldn't it? I would make, it would keep on iterating input. It would get an I here and an I there. And then finally it would, when I actually called this and evaluated it, it would look up the value of I and do I dot split, and they would all be the same. So no. Okay. For is that what I want? Yes. For die faces and count in L, our list of pairs, print random.randint 1 and die for x in range C. Did I miss a what's it? Okay, there we go. D3 10, 3, 50 and 5, 20 and 2, and how about 108? 3 values between 1 and 10, 5 values between 1 and 50, 2 values between 1 and 20, 8 values between 1 and 100. So there's also that. Works great. And with one function. So anyway, I think I prefer this one. So we have to evaluate this list. Actually, yeah, we have to evaluate it and save each number first before we yeah. I don't know if that was entirely clear, but square brackets means it's a list comprehension. Parentheses would just be a generator expression. If I had just made a generator, then it would not actually do anything yet. It would just kind of set it up to be able to go through later. So when I did for DC and L, it would that work? I'm gonna try once more. Where are the scoping rules? And one more of these. Okay. D3. 5, 2, 9, 6. Yeah, see, it's doing them one by one. That's another demonstration. of what's happening. So when I have the list, it evaluates it right then. The list, I mean this one, means as soon as it executes this statement, it is going to start doing this, calling input until it gets to this, and when it gets an input, it will map the result to integers on a split. So it'll create all of that first, and then it will go through and print each one. This, on the other hand, just sets it up and doesn't actually do anything. And then when we iterate over it, says okay. So when we do for DCNL, it says okay, now I need the first one, the first D and C in this generator. So it does okay, let's get the next one with next, right, that function, and that prompts for input and then splits it, etc. 2 and 3, and then does this and prints the result, and then it goes to the next DNC, and that makes it go to the next input. So instead of asking for input a whole bunch of times and then processing and printing something out of it, we're going to just go through something and get input and print it, and get input and print it. So there is an interesting little difference right there. I try to use generators when possible because lazily evaluated means doesn't block everything while it's running and doesn't have to store anything in memory. The classic example, I think, is probably range. Actually, in Python 2, the range function returns a list. In Python 3, the range function returns a range object. Python 2, there's xrange, which is a generator. If you say my range equals range of a 1 with like 20 zeros after it, in Python 2, your computer will be unhappy. In Python 3, it won't much mind. In Python 2, if you do xrange of this instead, it will be fine, but then if you want to check for membership, like a number in my range, then it has to go through each one and check if it's valid. So it doesn't take space in memory, but if you want to check for 9999999 in 10000, like something near the end, or even just a 1 with 20 zeros after it, in xrange 1 with 21 zeros after it, 1 with 20 zeros is still pretty big, and it'll need to iterate that many times to find that number. So it doesn't have to store each one, but it does have to check each one. Python 3 range doesn't do any of that. For example, if you wanted to check -1 in range large number, and let's say the large number, -1 in range really big number, what do you think the answer will be? And a range object is, if you only give it one argument, it's 0 to whatever the number is that you pass it, exclusive. So it goes up to 999999999. It isn't, is it? Because it's -1 and it starts at 0. So you immediately know that it doesn't work. In Python 2, this would take a very, very long time and eat up a lot of memory. Or you could do this and make it merely take a long time. But in Python 3, it just says no, it's not, because they start at 0. Or how about 3? Is this? Yes. Now how about from 1 to here? It is. How about if we do every third? It is not. Notice how it's fast? That's because it has actual logic in it rather than just making a large sequence of some kind and going through it. Anyway, that's lazily evaluated objects versus eagerly evaluated objects. I tried to make generator style stuff when possible, but it isn't always, depending on what behavior you want. So with that, I think that will be the end of the stream. And thanks for watching. Tomorrow is going to be a game of some kind, don't know which. And actually maybe Star Trek Online. My newest character has finished the tier 5 reputation for everything, but a few of those don't just give you the tier 5 reward as soon as you finish it. Most of them are like, you finished tier 5, and you get hailed by a contact and it says, here's a mission, and talk to me again to complete it, and thanks for completing it, here's a bunch of stuff. Some of them don't do that. You need to go somewhere and do a mission and do other things, and then they give you stuff. So maybe I'll go through that and show you what you have to do to actually unlock those things, because some of them it's really not clear where you have to go and what missions you actually have to do. Thanks again for watching, and we'll see you next time. Have a good one.